All right, good morning and welcome back. Today we are going to talk about trig identities and also with trig functions, how we can simplify them. Okay, so if we look here, a couple things, get out your note packet, 7.2. Also, you want to have your unit circle because we're going to talk about this in just a minute. Forgot to clear this. Let me get rid of that quick. So have that handy because we'll need that in just a minute. And then we're going to be on 7.2. So if you think about it here, this is the sine of theta times the cosecant of theta. And our job is to simplify it to a single trig function with no denominator. Now, on this first one, that's not going to come up, but with no denominator, I'll explain what that means on the second one in just a minute. So sine of theta times cosecant of theta. Now, sine of theta, if we were to rewrite that as a fraction, just be sine of theta over 1. However, cosecant of theta, if we think about it, and if you don't remember them, that's okay. Look at the bottom of your unit circle. Here, cosecant is 1 over sine. So I could rewrite this as 1 over sine of theta. Now, if we look here, sine of theta, these cancel out. And our answer then, 1 over 1, or 1 is our final answer. Now, on number 2 here, secant of theta times cotangent of theta. So we look secant of theta over here, 1 over cosine. So I'm going to put 1 over cosine. And the thetas, if you want to put them every time, that's great. If you want to just wait till the end, we need it at the end. But just to save a little time, I'm not going to put the thetas every time. So 1 over cosine, it's the same as secant. Okay, and then cotangent, if you forgot that one, cotangent is cosine over sine. X over y or cosine over sine. So we multiply that by cosine over sine. Okay, at this point, our cosines cancel, and we're left with, oops, let me switch to blue, there. So 1 over sine. Now here's what we're talking about. In that case, the trig function is in the denominator. We don't want the trig function in the denominator. Kind of like when we rationalize our denominator, we want that sine not in the denominator. So 1 over sine, if we look over here, 1 over sine, right here, that's cosecant. So our answer is actually cosecant. Now here we need to add the theta back up. So cosecant of theta. Okay, so example 3 here. This one starts to get a little longer, but it's the same exact approach. So cosecant of theta, as we just said, we know is the same as 1 over sine. Now tangent, that's our y over x, or sine over cosine. Cotangent's the reciprocal, so cosine over sine. And then cosine at the end here, that'll stay just the same, cosine over 1. So we start canceling things out. We've got a sine on the bottom and the top, cosine on the bottom and the top. 1 times cosine is what's left on the top, so that's just cosine. Sine times 1 is left on the bottom, so that's just sine. Now cosine over sine, if we aren't sure what that is, remember right here we already had it, that is cotangent. So if we multiply all this together, it actually just simplifies to cotangent of theta. All right, example 4, sine of theta over cosine of theta. This one's hopefully pretty easy. Sine of cosine, right there you see it. This one's just going to be tangent of theta. Okay, so now example 5, cotangent of theta over cosecant of theta. Now cotangent, we already said, we saw this in example 4, cotangent is cosine over sine. And then that's divided by the cosecant, which we know is 1 over sine. Now at this point, if we're dividing by a fraction, that's the same as multiplying by the reciprocal. So cosine over sine times sine over 1, that's the same thing. Those signs cancel out, and we're left then just with cosine of theta, technically over 1, but you can just leave it as cosine of theta. Okay, the final one on the front side, notice here we have cosine squared of theta. That's just the same. If we square something, cosine times cosine, it's going to become cosine squared. So it's just the same thing as what we've been doing. We'll have cosine of theta squared over 1 times, now instead of tangent squared, it's just going to be sine squared of theta. We can rewrite it over cosine squared of theta. Okay, it's the exact same thing as we break it apart. And if we switch there to red so I can cross things off, the cosines cancel out. And we're going to have sine squared theta over 1 as our final answer, or just sine squared theta right there. All right. So go ahead, flip it to the back. And now for this next one, before we talk about this, we're going to want to look at something called our even or odd identities. So if you go to that orange paper we have and flip to the back here, even odd identities, they're already written here for us. Sine of negative theta equals negative sine of theta. And we're going to talk about why. So let's start here with sine. So sine of negative theta equals negative sine of theta. What that means, if I choose a value of theta, so say I use 30 degrees. If I'm trying to find the sine of negative 30, now negative 30 would drop 30 this way. So let's think about originally sine of theta. So if theta is 30, sine of 30 would be 1/2. Now the sine of negative theta, so drop down 30, that's negative 1/2. It's the opposite. So if you look here, if you take the sine of negative theta, it's the opposite of the sine of theta. But with cosine, it doesn't become the opposite. And the reason why, once again, if we choose 30, right here, cosine of 30, square root of 3 over 2, whereas cosine of negative 30 is also square root of 3 over 2. So cosine of negative theta is the same as cosine of theta. Now, likewise, sine and its reciprocal, they will both be opposite. Cosine and its reciprocal, they'll both be the same. Tangent and its cotangent, its reciprocal, they're both opposite. So here's our rules. If you don't have your orange sheet handy, you might want to take a screenshot of this. So pause it, take a screenshot, that's fine. But let's talk here now. So sine of negative theta, as we just showed, that is negative sine of theta. And if you don't have these memorized, that's fine. I don't expect them to be memorized, but I expect you to be able to find this on the back of your orange sheet. Okay, so now secant of negative theta. If we look here, secant of negative theta, just secant theta. And our last one in this section, cotangent of negative theta. Cotangent does switch, so it'll be the opposite of cotangent of theta. So negative cotan of theta. Those are our three answers. Okay. And we're almost done. The final section here are Pythagorean identities, and we'll talk about what these mean. So Pythagorean identities. Now, first off, you'll notice on your sheet, you only have these top three. So if I were you, maybe pause, fill these in, or you can watch the explanation and then pause in a little bit to fill them in. So let's talk about why these are true. So Pythagorean identities, hopefully you know Pythagorean theorem, right? A squared plus b squared equals c squared. If we think up here to our triangle, I don't know if you guys remember, but back in like January, we said if we draw a right triangle here, so if I would label this side A, B, C. Now, we know a squared plus b squared equals c squared. In this case, c is 1 because it's a unit circle, so 1 squared is still 1. A would be like cosine, so cosine squared because a is our x value. B is our y value, or sine, so sine squared. And if we look down here then, you'll see sine squared theta plus cosine squared theta equals 1. So that fits our scenario. Now all we have to do is manipulate it to get these other two options. These are just different versions of the same. Kind of like how your name, or for example, my name, sometimes on mail it comes Matthew Fox, sometimes it comes Fox Matthew. It's the same thing. It still talks about me. If we move it in a different order, sine squared theta plus cosine squared theta equals 1. If I subtract this over, then 1 minus sine squared theta equals that cosine theta squared. Okay, in the same way, if I subtract that over, I'll get sine squared theta equals 1 minus cosine squared theta. You can do the same thing. We could prove all of these. I'm not going to just to save time because we've already talked about them some. But here's the two that you have. If we manipulate things, we can get these other 6 below. Okay, so you might want to jot those down if you don't have it. Pause it. And let's go ahead and finish up. So right here, 1 plus cotangent squared of theta. And if we look over here, 1 plus cotangent squared of theta equals cosecant squared theta. That's all we got to do. Now example 11, sine squared theta plus cosine squared theta. Right here, that equals 1. Secant squared theta minus 1. Okay, this last row here, we look, secant squared theta minus 1, that's just tan squared theta. And we're just about done. The final one. Now on this last one, it's a little more difficult. We're going to have to use something called FOIL. So first, outside, inside, last. First meaning 1 times 1, that gives us 1. O meaning outside, 1 times negative sine theta gives us negative sine theta. Okay, inside, sine theta times 1, so that's plus sine theta. And last, that'll be negative sine theta squared. Okay, so sine of theta times sine of theta would be sine theta squared, but there was negative times positive, so that stays negative. Now hopefully you see negative sine theta and positive sine theta, those cancel out. So if we simplify this, it's just 1 minus sine theta squared. We go back here to our identities. 1 minus sine theta squared is just cosine squared, or cosine theta squared. So right here, cosine theta squared, that is our final answer. Okay, so that's all I have for today. If you have any questions, definitely reach out. Let me know. I am more than happy to help you. There is a short Delta math assignment for today. Please get that done, and we'll keep rolling tomorrow. So if you need anything, please reach out. Hope you guys have a great day.